I'm going to do the construction proof of the sine-sum identity. So first we are going to draw a line. And label it AB. Then we're going to rotate up and label this C. So now we're going to call BAC alpha. We're going to rotate up again, make another line, and call this line D. Now we are going to call CAD beta. Okay, we're going to make another line starting from D and make it perpendicular to AB. Go ahead and show that it's a 90-degree angle. And we're going to label that E. So now we can notice that the sine of alpha plus beta, so this entire measure, is DE over AD. So I'm going to write that. Okay. So now we're going to draw another line from D perpendicular to AC. And we'll call that F. Now we're going to draw another line from F perpendicular to AB. We'll call that point G. Once again, it's a right angle. And we will make one more line from F perpendicular to DE. And we'll call that line, or that point, H. So now we can notice that HF is perpendicular to AB and AC is a transversal to HF and AB. So that makes this angle and this angle alternate interior angles. So BAC angle is equal to HFA. So those angles are equal. We also can notice that HFD is complementary to HFA because this is a 90-degree angle. So these two angles are complementary. We also know that this is a right angle. And so if this is a right triangle, then these two angles are also complementary. So HDF is complementary with HFD, and HFD is complementary to HFA. So that makes these two angles congruent. So now we have three angles that all equal alpha. Okay, so now we know that the sine of alpha plus beta is DE over AD. right there. And DE is also equal to DH plus, we could say HE, but HE is also equal to FG, so we'll use FG. So now we have sine of alpha plus beta is equal to DH over AD plus FG over AD. So now we are going to make these pretty by multiplying by a judicious form of 1. So sine of alpha plus beta equals, we'll multiply the left side by FD over FD and the right side by AF over AF. So now we can rearrange these numbers because multiplication and addition are both commutative. So now we can say the sine of alpha plus beta equals, we'll do FG over AF, which is right here and right here. We can just cross those out. Multiplied by AF over AD, which are right here. And then we can say DH over FD multiplied by FD over AD. Oops. Don't want to mark that out. Okay. So now we can look at these separately. So FG over AF is the opposite over hypotenuse of this symbol, which is alpha. So opposite over hypotenuse is sine. So now we have FG over AF is the sine of alpha. We also have AF over AD, so that's right here. AF and AD is the adjacent and hypotenuse of beta. So adjacent hypotenuse is cosine. So then that would make it cosine of beta plus DH over FD. And we said that this angle is equal to alpha. So then that would be the adjacent and hypotenuse of alpha, which is cosine of alpha. And finally we have FD and AD, which is opposite and hypotenuse of beta. So opposite hypotenuse is sine, so it's sine of beta. And that is the sine sum identity.